We are so fortunate to be able to bring together specialists in many fields who bring to life new studies and appreciation of Japanese arts and culture. We are so thrilled with the enormous response worldwide to our virtual programming that programs like this evening's can bring together scholars located in New York and Kyoto. As you know, we plan to continue this format for the foreseeable future. In our two-part series, looking at art through the lens of scientific analysis, we have invited Dr. Marco Leona, chair of the Department of Scientific Research at the Metropolitan Museum of Art, to explore the process by which new pigments were introduced into Japanese painting and prints. Last week, Dr. Leona gave us a very learned and compelling overview of the blues introduced from the 1820s on. Tonight he will be joined by the amazing historian Henry D. Smith, now Professor Emeritus of Japanese History in the Department of East Asian Language and Culture at Columbia University, who will be speaking to us from the very early AM in Kyoto. Those tuning into last week's webinar will recognize Henry as the author of the chapter in John Carpenter's Hokusai and His Age in 2005, where he wrote on Hokusai and the Blue Revolution in Edo prints that Marco cited last week, and also of Hiroshige, 100 Famous Views of Edo, among many, many important works. That particular volume means a great deal to me as it featured the Brooklyn Museum collection and was published by George Braziller from 1984 to 2000 in various editions. Both of our experts have been engaged in their own and joint studies of both blue and red, as well as purple pigments, and they will help us to understand the history of red pigments introduced slightly later in the 1860s onward. Collectors and scholars were once focused on aniline dyes for prints and textiles. This new research and analysis will reveal much more varied materials, both natural and man-made, as well as the myriad effects they achieved. We can ask, were artisans merely adding to the long-established red and purple pigments used in Japan, or was this an explosion of something totally new? We leave it to you, Marco Leone, to introduce this topic tonight. Thank you.
Thank you, Amy. It's again a pleasure to be here with you and the audience of the Japan Artist Society of America. I want to ask you something first. Is my screen clearly visible without a box in the middle that says this meeting is being recorded?
Yes, it looks good.
Great, and it's the audience view, right? It's not the presenter view.
Yes, yeah.
Great, thank you. So this is really something that was in my mind almost as soon as I started looking at blue. The evolution of color choices and material availability in Japan as the Meiji Revolution changed literally the world in Japan. I'm starting with a print by Adachi Ginko from 1887, so a long time after the Edo period ends, and the subject is not typical, not the usual Japanese print. It's a view of women sewing, showing Japanese women in Western dress making Western clothing. And if you know about sewing and clothing, you can literally go through this print and see that the implements they're using are those typical of the Western tailor and seamstress. That strange submarine-looking item that the lady in the center uses is what is called a chimney iron. It's a type of iron that had coals inside and that little chimney to have smoke and steam escape. Likewise, you can find whatever is used to trace patterns, to cut cloth, and all that, telling us really something that was happening, a transformation in fashion and clearly in the use of color. But I'm going to step back to the end or to the later part of the Edo period to make the point that the transition from Edo to Meiji period was a time of great technical innovation in Japan, and something that with scientific analysis, we can trace. These two prints from the Waterfall series by Hokusai belong to what Roger Keyes called set A and set B. So on your left, set A, the original print by Hokusai. On your right, set B, a group of prints that was, according to Roger Keyes, printed from recut blocks in the Meiji period. And one of the things that we discovered is that as we transition from the Edo period to the Meiji period, something is happening in the use of yellows. There's a yellow pigment called orpiment, traditionally used in Europe to paint gold details in paintings because it's a rich yellow that looks like gold. Orpiment means, from the Latin, the gold pigment. And the print used by, the print by Hokusai uses a natural form of this mineral, while the print made in the Meiji period uses the same chemical, arsenic sulfide, but obtained through a synthetic process, which rather than offering a crystalline material, so like the pure mineral, offers a more amorphous material. So there was an industrial process that allowed to obtain a costly pigment, a relatively costly pigment, in a different way. And this is something that we see happening in the Meiji period, but whose the beginnings of the process were already in the Edo period. And we documented this. I just want to put out these titles. These are articles we published, and they're easily accessible because they're published in an open access journal. It means that you can just Google, for instance, arsenic sulfide and my last name, and you will find them, and you can download them if you want to read about them. But our study from our early article documenting that in the Meiji period, this yellow was predominantly made, or actually uniquely made with the synthetic method, while in the Edo, we have the natural mineral, then culminated in a later article which compares some impressions of Hokusai prints, showing that already in the later Edo period, there was some experimentation with methods of refining, modifying, and eventually wholly synthesize these yellow pigments. So let me close the mineral pigments, poisonous pigments chapter and go to the topic at hand, which is red. And by red, really, we're going to take a broader view, and pink and violets will also be part of it, mostly because you mix a little bit of red and a little bit of blue and you get pink and violet. For most of the history of woodblock printing, and certainly for most of the history of humankind, only natural colors were used, or the majority of colorants that were used were natural. Minerals, but very interesting, organic pigments, so pigments made of carbon, oxygen, nitrogen, occasionally sulfur, and other light elements, could be obtained from plants or insects. We have lac dye, cochineal, and others are made from insects, but then a variety of materials are made from woods, from saffron, turmeric, the flavone yellows from weld and others, berberine, very important in Asia. These were used as textile dyes, uh, as colorants for food, cosmetics, and very importantly, in Japanese prints. Not a lot of study has been done on these materials really as it applies to East Asian pictorial works of art because of the complexity in identifying this material without taking large samples. Uh, More recently, using non-destructive and microanalytical techniques, we've seen a lot of activity. I want to just quickly cite the work done at the MFA Boston, where they did probably the most thorough survey of Edo period prints to identify natural organic colorants. Now at the Met, we've taken a different approach. We use a technique called surface enhanced Raman scattering, which uses lasers, silver nanoparticles to obtain fingerprint information on the colorants present in extremely small samples. So we have been taking little samples from our prints and often paintings, and we've been able to trace the use of dyes. Here you see the application, the method. Really, we use a needle to extract a sample. The sample is, in this case, 200 micron long, but it could be really much smaller. It could be like this, so about 50 micron, which is the diameter of a human hair. And then the final result is what we call a spectrum, so a graph where these lines occur in specific positions, giving us essentially the fingerprint of a dye. Each dye has its own fingerprint. We can compare what we obtain from an unknown with a reference. And so it was Henry Smith who suggested that to identify what was used in the Edo period in paintings as for reds, for these deep organic reds, we should look at these painting of gamecocks, two roosters, attributed to the school of Hokusai, the studio of Hokusai, and also possibly to Katsushika Oi. And I really need to thank Henry because he had looked at Hokusai's manual of painting and he said, there's an image that reminds me of the Met's painting, and it's this one, in which Hokusai says that to paint the red of the wattle and the crest of the rooster, you should use vermilion, the natural mineral, the mineral used predominantly in Asia for deep reds, arsenic, mercury sulfide, and then overlaid with Enji. Enji is this organic red, and that would give us an opportunity to find what it is. So we look at the painting. Here I am sampling at the microscope. You can actually see the microscope is behind me in my office. We wheel it to the Asian storeroom, and we found that it was lac dye. Lac dye is a pigment made by an insect. It's an insect cultivated in India and Southeast Asia. And more importantly, there's a beautiful letter by Katsushika Oi. The image comes from the British Museum catalog of the late Hokusai show, in which she shows how to prepare enji, taking the material in which it was available, a cloth, a cotton cloth dyed with these deep red, and with the hands here, she says, like, make it into a powder and then heat it in a little dish. So that was a beautiful confirmation of what Hokusai says. Katsushika Oi explains how to prepare, and then finally the painting showing it. This technique, because it allows us to study paintings and prints with minimal sampling, really was the key to study a very important problem, that of the aniline dyes. In 1856, William Henry Perkin, then 19, I think at home over the Easter holidays, playing in his home lab, discovers mauve. We actually made it in the lab, this first synthetic colorant. It's a horrible mess. And the fact that he was able to take the horrible mess that the reaction that he made produced and discover that it would yield a colorant, which in turn changed the world, is a testament to his curiosity and abilities as a chemist. Perkins' discovery of mauve, the first wholly synthetic organic dye, a beautiful purple, changed the organic chemistry industry. It really launched it, and very soon, Germany and France jumped in, and essentially all of the big chemical companies and pharmaceutical companies that you know today were launched. I want to point out that the year 1856 is 3 years after Commodore Perry arrived in Yokohama. So there is a really deep connection between the aniline dyes and Japan, certainly a timely connection. Very soon, companies sprouted. You see here Bayer. Yes, it's the same Bayer that made aspirin. You could talk about Agfa, Ciba, ICI, DuPont. They all started making dyes. Very soon, you start seeing these companies sending their wares all over the world. We have beautiful catalogs that show examples of the colors that were available. And you can really imagine a salesperson walking into a textile workshop or a printing business, opening these books or opening a suitcase and literally unlocking the rainbow. There's a beautiful book about the beginning of the chemical synthesis of dyes and the trading synthetic dyes called the Rainbow Makers. And I think that no title was ever more felicitous. So with this technique, surface enhanced Raman, and knowledge of what the chemical industry was creating in these years, we started, Henry Smith and I, to talk about assembling a collection, a group of prints from the Meiji period that could be used to document the introduction of these dyes into Japan. And Embry put together a collection, and I can show you a snapshot of it. By all means, not all of them, but as you know, using the system of sensor seals, you can have prints that are dated to the month of the year. And don't look at the dates. Don't look at the specific prints. Just take the overall view and see how the color is really changed. You know, if you were thinking of the 36 views of Fuji, if you're thinking of the 53 stations of the Tokaido, you'd see blue. Here you're seeing pink, red, violet. And I'm going to quote Henry, who has a beautiful phrase. He calls blue the modal color of Edo, and red the modal color, the most common, the most informative, the most predominant color of Meiji. He says it much better. We were not, of course, the first to talk about aniline dyes, certainly from the scientific point of view. My first reference was Pamela de Tristan, who in a conservation paper in 1997 started looking at these dyes, mostly from without analysis, but just looking at archival evidence and testing the chemical and conservation properties, the stability of what she assumed had been used at that time. More recently, and really at the same time as we were investigating our set of prints, Yamato Asuka, an art historian in Japan, completed a scientific study using non-invasive techniques on a group of late Edo and early Meiji prints, starting to identify and classify the aniline dyes present. Let me just go into the prints and the chemistry of what we found. And let's see how we develop a timeline for the introduction of synthetic dyes in Japan. The earliest, the late Edo period and early Meiji prints still see a lot of natural dyes being used. And one of the most representative loved for its beautiful, rich pink color, and when printed with numerous printings, a delicate red, was safflower, cardamom. This was native to Japan, cultivated in Japan, and very good for printing. We still see it at, past the discovery date of synthetic dyes. Incidentally, all the work that I will present can be found in this article. Again, if you were to Google my name with synthetic dyestuffs and Japan, you would find it, and it's available freely from the publisher. Safflower, as I say, is certainly dominant in the Edo period. We see it in the very early Meiji period, then it stops. Henry will say something, I hope, about this. In the first years of Meiji, though, we see the appearance of a new color. This is a print by Kunichika, and it's difficult to see from the screen, but what I did is I put side by side a detail of the front and the reverse of the print. And you will see that there are a deep, bright blue here, and not so easy to see on the screen, more violet color. If we flip the print and look at the reverse, though, the difference between the two blues is evident. One is just blue, it's a pure blue hue, but the other one shows a distinct pink purple tonality. And that's because they use two blocks there. The Prussian blue block, which contains this color, and then a block with a pink color that is entirely new to Japan. And that color is magenta. Magenta, the commercial name of one of the first aniline dyes, a class of dyes called triaryl methane, which is this chemical arrangement, has a beautiful, vivid pink color. It was also known with the name fuchsin from the flower fuchsia. It's really it's the second important synthetic dyes after mauveine, and actually it was commercially much more successful than it. Magenta is found throughout the early Meiji period to the end of the 19th century. Very soon, chemical developments produced a new dye, still related. You can still see these kind of propeller-shaped molecules, still the triaryl methane family, but it's called metal violet. This is a true violet. It's not a mix of blue and pink. It's a rich violet color, and we see it from 1875 onward. Incidentally, if you have a blue pen in your hands, chances are it contains crystal violet, which is a more pure type of metal violet. Metal violet is a family of 4 or 5 colorants that differ very little. Crystal violet is one of those ingredients. This print by Kunichika has metal violet, but was also shocking, because it's also my favorite of the prints we looked at, but it also was shocking because we discovered a colorant that we did not expect. The deep red that you see here is carminic acid. Carminic acid is the molecule responsible for the color of cochineal. Cochineal is a dye produced by a little insect native to Mexico. It feeds on the nopal cactus. It was probably domesticated something like 6,000 years ago by the native populations of Mesoamerica. When the Spaniards arrived, In Mexico, they noticed it immediately. And if gold caught their attention at the beginning, it really was cochineal that made them rich. The amount of cochineal that was transferred from Mexico to Spain and then on to Europe was extraordinary. Spain held the world monopoly, and if you wanted something that was scarlet or deep red, you had to go to them. It became the most desirable dye for luxury textiles, the most desirable red dye for paintings. And we don't see it in East Asian, in Japanese pictorial arts until now. This is shocking, and it's one of the things that we often find, just like we found looking at the Great Wave that indigo continued to be used after Prussian blue had arrived. So here we discovered that a natural organic dye was used. It came through the same network of traders and commerce that brought in the synthetic dyes from Europe. We see it essentially taking the place of safflower, 1869, and going on until the early 1890s. Very interestingly, it is used in the same way as safflower was used. Very often we see safflower printed over vermilion or iron oxide mineral reds that have a good covering power. Safflower is a little bit more transparent, but it lends depth when overprinted over these colors. And the same happens with cochineal, which was often combined with vermilion and iron oxide. This print about the Satsuma Rebellion is, I think, another iconic print of the Meiji period because the use of reds is really important there. A lot of blood, a lot of explosions, a lot of fire. When things calm down in Japan, we see here a more peaceful print with the emperor fully in his glory and in a more relaxed attitude. We see another dye coming in. The red on the ladies of the court gowns is still made with cochineal. I want to point out the violet, which was the most fashionable color in Europe at the time, used for the men's uniform. But this bright bluish pink found on the cherry blossom is a novelty. It's another synthetic dye that came from Europe, and it's called eosin. Was famously used by Van Gogh. Van Gogh loved it. He used it for flesh tones. He used it for pink purple details. It has a problem. It fades very rapidly. You see here, Van Gogh Museum Amsterdam is comparing the original appearance of the artist's bedroom with what it would have originally been with the accents given by the pink eosin. One of the things that's very important to me is how throughout this process of introduction of dyes, we see the Japanese printers, the master printers working for all of the various publishers, taking materials that are entirely new to them and learning very quickly how to use them skillfully. Eosin, starts in 1877, continues till the end of the 19th century. Often it is also used in combination with cochineal. Here we see where details where we have the deep red is cochineal, the pink is eosin, but then there are details where the two materials are printed over one another or mixed, which was very interesting to see. Finally, in about 1890, this is where maybe we get to the height of the crazy colors. I know that Henry doesn't want me to use these loaded adjectives, but this is when the Naphthal Reds arrived in Japan. These were colorants that had just been developed in Europe, very cheap to make. They afford really loaded, intense reds, and they start being used everywhere. They also are the least stable of all of the colorants we've seen so far. They're very prone to bleeding. And so they require extreme care in using, but the Japanese printers were able, as you can see from some of these examples, to use them quite well. But this is truly the height of the acid red fashion. This is it. This is the timeline. This is how, this is exactly when these colors entered Japan and how they spread. I want to just finish with a little note. Very often we talk about how the printers in Japan used colors that were fugitive without caring or without knowing. This painting by Van Gogh, irises, a very Japanese subject, and if I can say so, executed with more than a nod to the technique of Japanese printing, was described by Van Gogh as violet irises on a pink background. All we see today is blue irises on a white background. Van Gogh used carminic acid to make the white that you see now pink, and eosine to make the blue petals purple. They both faded. He knew that. He said, I'm going to lay it on thicker than normal so that something will remain. But this is a note of caution to us to use too harsh a judgment on an artist for his or her choices. And now, this is it for me. I think Henry will go on to comment on what really these colors meant and what their fame was, deservedly or not. So please, Henry, take it on from me.
Oh. Henry, if you could please unmute.
Can you hear me?
Yes.
Okay.
We can.
Now, do we have my screen? No,
Nope, so you need to share your screen.
share my screen. Go to basic,
Yep.
right?
Yep.
And go to share.
Wonderful. So
What is this?
that's just the WeTransfer up in the background. So if you pull up your keynote,
Yeah.
nope, there you go. And now if you go into view, and we can start the slideshow from the beginning. So view is at the top ribbon, at the very top of the screen.
View, of course, yes, yeah.
Yep.
And
oh no, sorry, play. I'm sorry, it's different in Keynote. There you go, so you can play slideshow.
Yeah. Mm-hmm.
Yep. Okay, great.
Okay. Okay, you can hear me? You can see the screen, right?
Yep, you're good to go.
Okay, let's go. Making Meiji Red, Science Tells a New Story. This is the title that I've been using for an ongoing project. It'll probably continue for quite a while more, but important to this is the word making. I mean it not just creating Meiji figuratively as somehow associated with red, which is certainly true, but very literally of making the material matter that appears to our eyes as red. And these are color woodblock prints. This is a famous, often mentioned Kunichika print from the 1850s that shows all the people who are they're depicted as ladies when of course in fact they were all men. But you see what a team of people it takes, all making something. So the artist is over here drawing the what will be the picture. Down here is a very important person who's often forgotten about, the person who sizes the paper. This is an important stage in preparing it for printing. Then you have the carver up here carving away, and someone up here is drying it, and finally the printer with all the printer's tools over here. So all of this is what goes, and red, there's red right there. All this goes into the making of the prints. I'm not going to deal with technical things right now, although that's a great interest to me. And these are the topics I want to hopefully as quickly as possible deal with. One, catching up with Berlin blue, a little bit more on blue. Then what benibana is the same as safflower. I prefer that word because this is the Japanese term. Safflower makes you think of vegetable oil in the grocery store. That's made from the seeds of one variety of the safflower plant. Benibana, it really means the red flower. And the shift to carmine, which is the word that I prefer over cochineal because it's the pigmented form of what the bug produces. And then the Naphthal scarlet, which Marco has already mentioned, and then a few words, if I have time, on the whole conception of the history of ukiyo-e. So what does the color red mean to the Japanese people? This is a quotation from Monica Beta, one of the great scholars of Japanese textiles and textile dyes, and in particular benibana. And in the wonderful Kosode exhibition at the Japan Society in 1984 catalog, she wrote, "To the Japanese, red represents color itself and is associated with the sun, life force, festivity, and healing powers." The healing powers is something we really need these days. And there's all sorts of evidence of this. So you find vermilion red scattered on Japanese tombs in the 17th century. You see the cheeks of a Haniwa figurine with vermilion on the cheeks, 6th century. So many folk toys now. You see the daruma in the middle, and other ones are in red. It is the characteristic color of these, what are really amulets. You buy it and you make your wish come true and paint in Dharma's other eye. These are all traditionally were made with bengara, iron oxide pigment. And this is, again, particularly appropriate to us today. Smallpox prints were printed all in red. This would probably be benibana, maybe iron oxide, as a way of warding off smallpox. Which was a great plague then. They had cholera as well. So it's protective. It's a healing color. Now, just a few words about the blue work that I did. First published in Japanese, actually, in 1998. That's 23 years ago now. But it attracted a lot of attention and then appeared, as Amy mentioned, in the John Carpenter's edited volume on Hokusai. And this is simply the opening to it. I just want to add one important new thing that has been discovered since I wrote this article. Then I argued, this print was the smoking gun in 1830 to make Berlin blue. And I call it, I can't give up calling it Berlin blue because the Japanese call it bero. And that's really what they mean. I know everyone else calls it Prussian blue, but I prefer Berlin blue. At any rate, it's a gorgeous color, a landscape of China. And we now know that the colorant itself, I presented this in my article as a hypothesis that I didn't really believe in, but it has now been absolutely proven that the Chinese made a factory in Canton to manufacture Prussian blue. And this is what made it available in such quantity at such low prices from the mid 1820s. The person who discovered it, Kate Bailey, you see her name there. I have never met Kate Bailey. I am told that she is, possibly was, a retired judge who was just interested in conservation studies, so signed up for some classes at the Camberwell College of Arts in London. And she was studying some Chinese materials. But by this time, the internet was available, and you can try it yourself. If you Google Chinese manufactory Canton, you will find all sorts of primary documents about this. Since then, I have discovered a particularly interesting entry. This is in 1822, which, as you see, notes the manufactory of Prussian blue has been established in the vicinity of Canton. And we can now date it precisely to the year 1822. So this is a real revolution, that the Chinese start making it in good quality and in huge quantity, and it takes over. It's a wonderful story. Kate Bailey's article also goes into some of the details of why the Chinese were so eager to manufacture Prussian blue. And one reason was that they wanted to use it to brighten up stale tea leaves to be exported then to England. It's a wonderful story, but just a story. So, and this is where Marco mentioned, I proposed that at the end of my article, that we could now perhaps look ahead to the Meiji Restoration, when red became, I call, the modal color of another era with other priorities, whereas Berlin blue was the color of expanding space. Meiji red was to become the color of accelerated time. I'm not sure whether this is correct, but it sounds good, and I think there's something to the idea. So now I want to jump to 1869, which we have seen was suddenly, and it really was sudden. It was within the space of about a month, in early 1869, probably in the first or second month, when the revered benibana, safflower red, was suddenly replaced by this insect dye known as cochineal, and in its pigmented form as carmine. It's a beautiful flower, absolutely gorgeous, and you can see it's made of really two colors. It's made of a red and a yellow. And the yellow is kind of a problem for safflower, because you have to wash it out to get a good red. So I'll show you a slide shortly in which you will see the kind of slightly more orangish color that it has compared to carmine. Safflower benibana began apparently in the Nile Delta, they say, made its way over centuries to Little Japan, and it was cultivated very widely. This is one of the plantations that they still have up in Yamagata Prefecture. It's become a tourist attraction more than anything else. And this will be the season very shortly, in early to mid-July, when they're all in bloom. It's then processed in a very laborious way. It takes a lot of labor, a lot of time, a lot of expense to make these little, they look like hamburger patties. They are little patties of the material that is then dissolved and used to dye textiles. This is not for painting. These are for textiles. But and then it would be taken down along the coast of Japan, from the port of I forget what the port's name was, and on and across land to Kyoto, which was the great dyeing center. The most prized use for benibana was for cosmetics. This is what gave it its cachet in many ways. And so you see a Kunichika Print, Kochoro, a woman who has already applied it to the lips and is now applying it to her kind of eyes. It was also used as a rouge. So this kind of gave the associations of benibana were something that women used to make their faces red, and particularly the lips. The lips were a printing technique of its own special sort. They would sometimes, benibana happens to be a dye that is, and particularly as a pigment, you have to do it several times before you get a deep color. So the printer would actually print from the same block 5, 6, 7 layers in order to get the perfect red from the lips. Why did benibana production decline in Japan in the 1860s, which it did, we know. And there are various theories, replaced in Yamagata by mulberry trees for silk, so that it could be exported through Yokohama. This is the most important, number 2, competition from imported benibana, which basically meant China, of higher quality. That people were complaining that Japanese native benibana from Yamagata was filled with stems and leaves, whereas this stuff from China was of higher quality and lower cost. Another theory is that there was competition from imported synthetic dyes from Europe. That's not really relevant, but the competition from the cochineal was very real, because cochineal was less expensive, not per unit, but it was a bit less expensive, and it was less laborious to dye or print. You only needed it once for the lips. Now, and just quickly, Marco has mentioned these red insect dyes. These are remarkable little animals that are spread throughout the world. Here you see some of the kermes in the Mediterranean area. There's an Armenian form, which is over in what is now Eastern Turkey. There is Polish cochineal, which feeds on the root of a plant. And then there is lac, this whole wide area in which the bug, even more remarkable bug that produces not only the red dye, but the lac that is used for lacquer for children's furniture these days. So there's huge plantations of it now. In the corners here are American cochineal, which was of a totally different species, existed both from stretching from Peru to Central America. I think people now agree that it originated in Central America, but Peru today is the largest producer of cochineal in the world, used mostly for food coloring. This is a map showing the world of cochineal in terms of its trade routes. You see, it's an extremely international. It is a true global product. What we're interested in is the route here from Central America, Guatemala probably at the time, and on across the Atlantic to be processed in Europe. These are high-tech photographs of the bug itself. Not very appealing. The male on the right lives for about 1 week while he mates and then leaves this world. And he has impregnated these, the female seen here, again, not very lovable, to be honest, when you look at it. They appear as these white dots on the nopal cactus. You see the red nopal fruits, which you sometimes see in your supermarkets in New York. And this is what it looks like. But then these are harvested laboriously. It's a real, a lot of labor. This is a wonderful photograph by Edward Muybridge on a cactus plantation for cochineal in Guatemala. In 1875, so this is a bit after when it was introduced to Japan. A photograph like this thinks, good Lord, this must be more slave labor, like people picking cotton in the southern United States. In fact, most of the producers of cochineal were independent farmers, and they worked very hard at this. It was a back-breaking, laborious kind of thing. Meanwhile, since 2006, quite recently, there has become a real, cochineal has become much more lovable, put it that way. Amy Butler Greenfield, A Perfect Red, is a wonderful book. And if you don't know much about cochineal, this is the one to read. It is well researched and very readable, a fine study. Meanwhile, there have been some important exhibitions, A Red Like No Other, in Santa Fe in 2015. Very nice, with a big, thick catalog and lots of very specialized essays. So there's been a huge amount of research on cochineal. And then more recently, in the winter of 17, 18, Rojo Mexicano, the grana, they call it in Spanish, cochinilla, in art. It's a beautiful catalog, but it's all in Spanish. But it was a wonderful, wonderful exhibition, much better, frankly, than Santa Fe, and particularly on the science. And the Met set the Shinobazu pond painting as well. Meanwhile, Cochineal was known in Japan before this point in the form of cochineal dyed wool, which is very prized by, in this case, this is a firefighter ceremonial coat from John Weber's collection, but more commonly for samurai, for their jimbaori, so for their decorative battle wear, which were really costumes in many ways. But so it was known, and many of these jimbaori now survive. So more than 100 surviving have been identified. So then it appears in prints suddenly. This is from actually 1869, as you see, the very year that it was introduced. And the first visible sign of it is that the surface area devoted to red expands suddenly. This was, with safflower, this would have been extravagant to have this bokashi, what they call tembokashi, the gradation coming down from the top, descend this far into the picture. And that's how you can tell what is suddenly going on. There is more red on the surface. And so you have, really dramatic cases like this where not only is it a gradation, but the entire background is solid red. This is called tsubushi. It was a basic technique from Harunobu on to the Nishikie technology to color the entire background that had not been done before. But now you have all in solid red. Whether you think this is gorgeous or not is a matter of taste, perhaps. This is from 1870, Kunichika Print. And I was particularly interested in whether, there had been anything like this before in the Edo period. And it turns out, in fact, yes. On the left, you have a Kunisada print from the British Museum from a whole series. Tim Clark, I remember showing me this, and I thought it cannot be possible that they did this in the late Edo period because it was so extravagant. But they did, and it was extravagant. It was a particularly prized series that was financed by a collector, and they're not all red, some are blue, but this solid red background had a precedent in a luxury print. So now luxury becomes common. One thing to notice, I mentioned that safflower tends to be a more orangish, and you can actually detect the color here, that there's more, slightly more yellowish in the print on the left from 1863, but they're not far apart in time. Why didn't we know about cochineal carmine and Meiji prints before? In Japan, the printers who were using it knew it. They had a word for it. It was called yoko. And if you look in dictionaries at the time, here in this case, it's from the Tokuno report of 1892, in which they identify it precisely as yoko, a kind of scarlet imported, and probably carmine, formerly the best kind of safflower, was very popular, but it was too expensive. So yoko had the advantage of price. This is the word in Japanese, yoko, Western beni, which is a problematic word unless you simply look at dictionaries of the time. Here's Hepburn's 1887 dictionary, where yoko in the dictionary is cochineal carmine, and conversely, cochineal is yoko or cochiniru. So there's really no doubt about what it was, and yet no one cared. I think that's the basic answer. I have compiled some of the opinions of ukiyo-e experts, fairly recent, on up until 2016, who just explain what they think yoko is. This is Yoshida Teruji. Here, Ukiyo-e Jiten, a classic reference work, says yoko is an imported mineral red. Where this came from, God only knows, but it was then copied in the definitive Genshoku Ukiyo-e Daijiten, this great encyclopedia of ukiyo-e that simply copies Yoshida. Then in 2008, it's identified as aniline. And this is a common conception that yoko did not mean cochineal carmine, which it really was, but somehow it was an aniline dye. This is 2008. And in 2016, here a real expert in prints explains that aniline came to Japan in the late Edo period. It was garish, created a fresh impression, and paralyzed the color sensibilities of ordinary people. This is the mentality that has evolved Annalyn, but was really Cochineal. You know, it's a mess and remains so. So finally, the stage of what I call taming Meiji Red with Naphthal Scarlet. From 1889, we can date this quite precisely. Marco has already shown this print. This is the one that first caught our attention as possibly the smoking gun, and particularly from the bleeding through on the back, particularly when a print is backed. It has to be covered with wet paste, and this draws out the colorant. So if you ever see this on the back, that's the telltale mark of a synthetic dye that has been bled through to the back. And and Anna Cesarato, who was doing the real hands-on research in all of this, analyzed it, and this was the first time we discovered categories. They were typically known as acid red, a rather expressive term, but they're all from the naphthal category, and there's several of them, but they're all closely related. This was the first print that we found in which we could identify the colorant. This is from a kabuki print from October of 1889. So we surmise, you know, they may have appeared earlier, but we can't find any prints with it. One of Anna's key theories was that it may have been introduced through colorants that were used, dyes that were used for lithography. And I was able to acquire this, I find it charming, print, artist unknown, and it's dated. Most of the color lithographs are not dated in Japan, but it's dated very precisely to October 1888. So this is just the same period, but a bit earlier, from a series of beautiful women. And Marco analyzed this, and he said, sure enough, this is one of the naphthal dyes. This is a frequently shown print of the promulgation of the Constitution in March of 1889, and this is the traditional carmine, cochineal. So sometime this is just before, and the others are just after. We can see it happening in real time. I don't know. There's not much time left, so I'm going to have to just rush through some of this. This is a print that I always coveted and finally acquired a copy from Yoshitoshi's Great Moon series. The filial daughter, Chikako, presumably leaping into the river to sacrifice her life and get her father out of jail. It turns out that's not a true story. She actually lived on for a long time and got a famous poetess. But it's a beautiful, beautiful print, and the handling of color indicates the kind of sophistication that is emerging precisely as this new red dyes appear. You can tell it's naphthal red because if you turn it over, that's a backed print. There you see the signal that is red. And if you look closely at some of the text here, you can see a slight blurring. At any rate, in the 1890s, there's a whole transformation of woodblock print, not becoming more garish and more colorful, on the contrary, becoming rather more subdued. This is a really good example. Ogata Gekko is a whole new generation. Apparently a book by Amy Regal Newland is just about to appear, maybe has appeared, about Gekko. This is from the Met. And you see using these kind of an ink painting essentially in the background, and with very muted color. This becomes typical a lot of Meiji prints. They're garish prints to be sure, but there's also a more painterly touch with many of the younger artists who are trained often in both Japanese and Western techniques. There are some really dramatic uses of naphthal red in the Sino-Japanese War of 1894-5. This is Kunichika, one of my favorite artists, who in the early Meiji period played a lot with light. What you see on the right, this great explosion, is nothing more than naphthal red plus orpiment. That's all it is. It looks like it's some sort of magic combination, but that's what could be done with what you had at hand. At this point, it was synthetic orpiment. Okay, 2 more minutes. The ill repute of Meiji Red. So this is, I keep talking about this. These are the words that are typically used to describe it. The Japanese, particularly if you know Japanese, is particularly doku dokushi, poisonously red, keba kebashi, the gaudy, garish, strident, shocking. And in terms of qualifying them, imported, cheap, German aniline, and then the German connection, I'll just come in a second. Now I'm just going to skip over some of these because this I mentioned before anyway. How and why did we come to believe the story of harsh, imported, cheap, unnatural German aniline dyes? And I want to I'm just going to jump ahead to what I think is a really important text. And this is James Michener's The Floating World, which appeared in 1954, was a very influential book. He was already a well-known writer. And it was the first, really popular, readable book. James Michener was a very opinionated man. And particularly when it came to the colors of Meiji prints, he he let out all stops. So already before the new dyes in the work of Kuniyoshi. So he's tracing it back before the synthetic dyes. One finds uses of colors that are sensational, capricious, and lacking in taste. But when vile German aniline dyes reached Japan, all restraint disappeared, and some of the most grotesque prints ever issued flooded the shops. It was the debasement of a beautiful and sensitive art. I am now able to track this way of thinking as actually beginning much earlier in the 1880s, but it continued and it built up and it fed on itself, and it really reached a peak in Michener. Things have changed a great deal now, as we all know. People are much more sympathetic to Meiji prints. Oops. Wait a minute. What am I having? Okay. I just wanted to mention some of these books. You notice that most of them are by Amy Newland, actually. The one on Gecko just about to appear, but all of these books by the Bruce Coates on Chikanobu, Amy herself on Kunichika, and this one on Koson, have really expanded our sympathy for the colors of the Meiji prints. And I think this will continue. So we've really reached, we're in a post-Michener era, thank heavens. My closing slide is just a pitch for the 2021 International Mokuhanga Conference in late November, where I will be giving a speech about my recent thinking on the 1890s and the importance of that period in the history of the color woodblock print. Thank you very much for your patience, and I'm sorry I went over a few minutes. So I should stop share?
Yes, please.
Okay.
Henry, thank you. It is such a pleasure to welcome you to our stage this evening. And together with Marco Leona, I think we've had one of the most extraordinary opportunities to see how we can better understand these prints in a way that in less than an hour, we have been fully reclaimed. And I just wanted to tell you there are several questions, and they're quite technical, and I don't know if we have time for all of them, but I want to make sure that, Marco, you have a chance if you wish to say something, or Henry to Marco, before we take one or two questions following that.
Well, I just apologize to Henry for talking too much, and to the public for having to see Henry rushed.
No, we have a chance in the future, both of you, to invite you back to continue the discussion, which I think people would very much appreciate. We have very much a professional audience of collectors, scholars, curators, and others who have a serious interest. And I think that that's something extremely important for us. So if you don't mind, we'll just take a few of the questions. And several people have asked us, which you may have answered. You can answer, Marco, perhaps a little bit. We've already responded to the question of safflower. Is it the same as Benny? But here is a question asked, what combination of colors making up a purple has the purple fading into gray versus into brown? Can you address that?
I would need to have specific examples. So so Cochineal tends to fade by going slightly colorless, and so eosine goes colorless. The metal violets, I think they turn to brown, if I'm correct. But otherwise, I'm not too sure on the answer to this question, unless maybe an example of a dated print that we can look at.
I think those of you who have a real deep interest will see in the video recording that will be on the Japanese Art Society of America website. We'll have a chance to look at many of these points once again that were answered as we moved along. But for instance, people may wish to know the accession numbers of certain manuscripts, including Hokusai's manuscript that was describing that preparation that you showed us earlier. I think that's in the catalog.
It's in the catalog, yes. I don't know. And Henry, you had sent me the Henry knows the question to these to the letter, to the manuscript.
Yeah, let me just add, that was not by Hokusai, but by his daughter, Oe. And it was a real discovery. It's a very, very charming drawing of these elegant fingers, which was her one of the hallmark of her painting, crumbling some of this, cotton, enjiwata as they call it, the lac soaked cotton, and making it into a pigment. And it's quite remarkable. It was not known until fairly recently.
Is there any other question that either of you would like to address?
There is one actually matter that I wanted to mention, and that is that both with benibana, with safflower, and with cochineal, these are the primary reds, but they are almost always mixed with some mineral or with the synthetic eosine, and you can see a clear pattern. Yamato Asuka's work made it quite clear that in the 1820s, for example, bengara, iron oxide, was very often added to benibana to beef it up essentially. And then you find red lead, actually, entan, being used from the 1840s on up until the opening of Yokohama. And then the opening of Yokohama makes a big difference because there are no longer any government restrictions on the sale of vermilion. So vermilion becomes cheaper, more available, and you now see much more. It is the prime, ancient, costly red pigment synthesized in Europe and in China alike. But that now is mixed very often with the new carmine. And then when eosine appears as a way of, again, I don't, Mark, you would have to say, what does eosine do? I'm not sure, but this is something the printers are just doing on their own. They're experimenting, kind of winging it, and so we find that it's more complicated than just these plant or insect dyes alone, these natural dyes. But traditional mineral pigments are also being mixed in regularly.
Yeah, I mean, the connection, and so there was a question about why eosine is split in time, and that's entirely my error. I took an earlier graph from our timeline rather than the one we published. Essentially, we hadn't filled that gap by prints that contain eosine at that time, but we see it throughout. And 1877 is the earliest we find it. I think it's really the appeal of the unique shades, because using gives this unique bluish pink. So it's a cool shade of pink that it's very difficult to obtain otherwise. Some madder lakes tend to have that color, but none quite so characteristically as you've seen. And that's what made it attractive to the textile industry, to the painters, to the, and in this case, to the printers.
Well, I would like to thank you both, Marco and Henry, for your fascinating insights into this subject. We will all look at prints and paintings of this era through truly a new lens. I'm sorry that we have to end our program at this hour, but I hope we'll all get together with these two very, very impressive scholars in our field who have offered their insights into this subject again sometime next year. For those of you who are interested, please do join us for our next program on July 13th at the same hour for our next lecture when Rhiannon Paget, curator of Asian art at the John and Mabel Ringling Museum of Art in Sarasota, will present her current exhibition on the works of the printmaker Saito Kiyoshi and a transformative gift to her museum by collectors Charles and Robin Citron. Thank you all for joining us tonight, and we look forward to seeing you again.
Thank you, Amy.
Thank you.